Hi, this is Mick Elliott from Electronic Specifier at European Microwave Week. I'm on the Keysight stand with Randy Becker, Applications Engineer. Randy, 5GNR test is presenting some challenges for test companies. Maybe talk us through how Keysight is helping engineers overcome those challenges.
Absolutely. So there's a number of challenges associated with new radio. So I'll mention a few here. So number one, new radio, to get the wider bandwidths, we're going to higher frequencies. At the higher frequencies, we have much higher losses. So in a piece of test and measurement equipment, particularly on a signal generator, you're going to want to have high power capability. Another one would be for new radio, you're going to have that close subcarrier spacing, so you're going to want to have low phase noise in your test instrumentation. And another obvious one that comes to mind, new radio, like LTE, is going to use spatial multiplexing, and there you're going to need multiple channels to do the generation and analysis of new radio devices.
Yeah, okay. You mentioned the higher bandwidth moving now, which is the FR2, I guess, approach, and that is presenting some challenges to the industry with kind of beam forming and other areas. So what's Keysight's approach there?
Well, I could mention a couple of things. In fact, behind me we have a test and measurement setup showing this exact stuff.
Excellent.
And this particular instrument here we call the UXR. It's our newest oscilloscope. And normally you'd think of a scope as a fine time domain machine, but here you can see I'm making RF measurements with the scope. And why I'm doing that is because a scope has multiple channels, and I'm actually doing a 2-layer spatially multiplexed demodulation of my new radio signal at 28 gigahertz.
Okay.
Now the cool thing is, when people talk about bandwidth, yes, new radio has more bandwidth, component carriers from 100 megahertz to 400 megahertz, and maybe you have multiple 400 megahertz component carriers. So maybe you have 800 or even 1.2 or 1.4 gigahertz of bandwidth, but consider this scope has an instantaneous bandwidth of 110 gigahertz.
Okay.
From 0 to 110 gigahertz, every acquisition you have the full bandwidth, all channels, all the time. I mean, if you want bandwidth, Keysight knows how to do wide bandwidth. This is the widest in the world, nay, the planet, the universe.
Okay. But looking at, what about FR1? Because that's still being used, and that's a kind of proven technology, but there's still be engineers out there needing to use that. Are they still covered by what Keysight can produce? Or?
Absolutely. So all of the stuff we're doing here in this FR2 demo is applicable to FR1.
Okay.
And a quick example of that, we've added some new measurement capability, really help engineers visualize what's going on with these OFDM signals. An example of that is this trace here in the middle, which is the 3-dimensional view of how the power is distributed across time and frequency. And if you think about QPSK modulation, if you're familiar with QPSK, 1, 2, 3, 4 points. From the origin to each location is the same length vector. You would agree?
Yeah.
But the denser the modulation, the more different length vectors we could have. So in this plot, if I make it bigger so you can really see, you'll notice that you see this green signals, they're in one plane because they're transmitted with QPSK modulation. So all the symbols are at the same power level. But if I rotate this over here, you see 3 distinct power levels for the orange channel. That's because it's using 16 QAM. I'll leave that as an exercise for you to figure out the power levels, but that's how it works. And so across time and frequency, you can really visualize individual symbols and subcarriers. I can zoom in as far as I want to really an individual symbol or subcarrier. I can pan around and find the problem that might be occurring in my device under test. So it's stuff like this that really helps people unlock their next measurement insight.
Randy, that's terrific. Thank you very much.